In this video, we are going to answer very common GCSE exam style question step by step. By the end of this video, you will be able to calculate moles for any chemical reaction with confidence. It's actually very simple once we follow step by step method. Say to yourself first, I can do it. In summary, from the previous videos, 1 mole of carbon atoms, mass is 12 gram. The number 12 is relative atomic mass or RAM, or the symbol is AR, which you can find in the periodic table for each of the elements. Using this, you can find RFM. All you need to do is add up the RAM of each atom of the element. We also learned about the equation for conversion from mole to mass. N equals to mass M over MR RM RAM. We arrange the equation to calculate the unknown factor if we have to calculate mass M. So we rearrange it to find it N times MR. If mole is given, we can calculate the mass like this. Keywords we learned are listed here: mole, mass, relative atomic mass or RAM, relative formula mass or RFM, and molar mass. If you're not sure of these, please click on the previous videos in this playlist of moles calculation. Let's start with something simple. In this chemical equation, hydrogen is reacting with oxygen to make water. In GCSE, you will get questions like this. 4 moles of hydrogen reacts with oxygen. How many moles of water is produced? For this, step 1, we need to balance the equation to show each side of the chemical reaction has same number of atoms of hydrogen and oxygen. This means on the left-hand side, we have got 2 times 2, 4 hydrogen atoms. It's same on the right-hand side as well in water. On the left-hand side, we have got 2 oxygen. You see O2, and in front of O2 there is no number, that means 1. So O2, 2 oxygens, that is same on the right-hand side as well in water molecule. So this equation is balanced. Now the number in front of the chemical is the number of the moles, which we'll be using for calculations. From this equation, we can say 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. So 4 moles of hydrogen is double of 2, isn't it? That means water produced is also double. That means 4 moles of water produced. Alternatively, you can think the ratio of hydrogen to H2O is 1 to 1. If you're asked for 4 moles of hydrogen, how much water produced? 4. For 10 moles of hydrogen, how much water produced? 10. Simple, isn't it? Now tell me, if 7 moles of hydrogen is used to react with oxygen, how many moles of water is produced? The ratio of hydrogen to water, 1 to 1. If 7 moles of hydrogen used, water produced, also 7. Isn't it? Well done. Next, we are moving forward. We are working with oxygen now. If 7 moles of oxygen is used to react with hydrogen, how many moles of water is produced? Tell me what is the ratio here for oxygen to water? From the balanced equation, we can say 1 to 2. In the chemical equation, we have unwritten 1 in front of oxygen, no numbers. So that is why it means 1. Water has got 2 in front of it, so 2. The ratio is 1:2. Simple. Now, oxygen used in the chemical reaction, the problem they gave us, is 7 moles. Water produced, how much? Double of it, 1:2. Always remember. So, 14. That's it. Now, this is the main concept of mole calculations. Now, if in the exam they ask to you to convert to mass, they have asked you how much mass of water is produced. So you need to use that equation. Before, tell me what equation is that? Absolutely, this one. N equals to M over mR. Now we are finding out not the moles, we got the moles, we are finding out the mass. So we have to rearrange this equation to M equals to N times mR. mR of water is 18. We multiply that with the number of moles, we got 14, so we get 252 altogether. That's it. Yay! Right. Now, some people find it easier to work it out in simple tables, converting moles to gram. You can do it in table. That helps in thinking process step by step. Step 1, balanced equation. Step 2, moles ratio, hydrogen to oxygen to water, 2:2:2, 2:1:2. That we have seen already in the previous slides, isn't it? Now, in this question, they have not asked about hydrogen. They only have talked about oxygen. So at the moment, we are not bothered about the hydrogen, we'll not calculate hydrogen, we'll only think about the oxygen. So what is the ratio? Oxygen to water is 1:2. 6 moles of oxygen reacting. So water produced 12, double, isn't it? Easy peasy. So we can stop here if they have asked about how many moles of water produced. But they have asked about how many grams, that means the mass, we have to convert. Using which equation? Same equation, M equals to N times mR. So here I've shown you that if 1 oxygen mole is been converted to 6, so 6 moles I have used in this reaction, how much water will be produced? 12, double of it, 1:2 ratio. Next, in step 3, we are finding out the RAM from the periodic table. So for hydrogen it is 1, for oxygen it is 16. From there we can find it out, the RFM. So H2O has got 2 hydrogen, so 1 times 2 plus 16 equals 18 is RFM, relative formula mass of water. Next, in step 4, we are finding out the mass. We have got the moles, we are finding out the mass using the equation M equals to N times mR. So here I've done it for you. So 12, we have got the number of moles of water produced in step 2, 12 times 18, that is the RFM of water, equals to 216. Have you got the same number? Well done. This is the massive step in moles calculation. Now you can solve any problems or for any equations. We will work together now a few more problems just to build the confidence, and then in the next video I'll explain the past paper questions, so watch out for that. So here, same problem with different numbers. Pause the video and do it yourself. This is to check your confidence and to see whether you can do it and build confidence. You can organize your thoughts with the table as I have shown you, or you can directly show the work as you wish. Have you got it? The answers? So let's go through it. Step 1, write the balanced equation. We got it. Then step 2, use the mole ratio. We got it. Hydrogen to oxygen to water. 2 is to 2, 1 is to 2. 2, 1, 2. So 2 moles of hydrogen reacts with 1 mole of oxygen to make 2 moles of water. So from there we can say 10 moles of hydrogen reacts with 5 moles of oxygen to make 10 moles of water. Now here is a little trick. In the question they have said 10 moles of hydrogen and 10 moles of oxygen. Now 10 moles of hydrogen only can react with 5 moles of oxygen because the ratio is 2:1. So it will not react with all of the oxygen. Some oxygen will be left over. Okay, so we got 10 moles of hydrogen reacts with 5 moles of oxygen to make 10 moles of water. Step 3, work out the MR. We have done it already before, so you know it now. 18 it is. Step 4, calculate the mass. So mass here for the water, N times MR. So 10, the mole we have got in step 2 times 18, that is 180 gram of water. That's it. Now, if you follow these 4 steps every time, you cannot go wrong. Now, this is a different question, but same concepts, same 4 steps. Pause the video and first try it yourself, and then we'll go through it together. Have you done it? So let's go through it together. Step 1, first thing, balanced equations. We got it here. So copper carbonate making copper oxide and carbon dioxide. It's already balanced 1, 1, 1. So we are going to use this into this equation. So in the table, write down everything. So step 2, moles ratio from the balanced equation 1, 1, 1. Mass reacting, they have said in the question 15 gram. So they are asking calculate how many moles is it. So for that, we need to find out the moles. So from mass to mole. So you know which equation to use here. So for that, step 3, first thing, finding out the RAM and RFM. So relative formula mass for copper carbonate, we can calculate 63.5 is for copper, RAM for copper. You can find all of these from the periodic table if they have not given you. So I've written down in the corner of the table all these numbers, plus 12 for oxygen, for carbon, and for oxygen 16 times 3 because there are 3 oxygen atoms in copper carbonate, CuCO3. Altogether you get 123.5. Now next, copper oxide, CuO, so 63.5 plus 16, 79.5. Carbon dioxide, 1 C and 2 oxygens, so to add up 44. Now going to step 4, because they have asked how many moles. So 15 gram for copper carbonate. So we divide it with MR, 123.5, we get 0.12 mole reacted for copper carbonate. So that is the answer I've written down on A. Then next question is how many moles of copper oxide is produced? So we need to think about the ratio. It is 1, 1, 1. So if it is 0.12 moles is produced, is used copper carbonate, 0.12 moles. So we got 0.12 also for copper oxide and carbon dioxide, 0.12 moles. Now, question C, they have also said how many grams of carbon dioxide is produced. So you see, we have to convert it now from mole to mass. So we are going to use this equation M equals to N times MR. So we got the mole 0.12 times MR, 44. For carbon dioxide, we get 5.28 gram. So that is the final answer, 5.28 gram and 0.12 moles. Have you done it all by yourself? I know you are now the expert of these calculations. So in decomposition reactions, always check the mole ratio, and it's often 1:1, which makes this kind of calculations easier and quick. You don't have to really balance, but check it. Step 1 is balanced equation. Otherwise, the calculation can go wrong. Next problem. I'm sure you have become an expert on this topic by this time. So go ahead and do it yourself. Pause the video and reveal the answer when you are done. Okay, have you got it? Here, if you got 22,400 gram, wow, brilliant work. So you have learned how to do it, but now what you have to do is practice more. So what you can do, go to the website to download more worksheet on these problems and do it yourself. Next video is calculation of moles in chemical reactions from the past paper questions. So don't miss it. Also, you need to know the exam tips, where not to make mistakes, and of getting full marks. Hit the subscribe button below if this video is useful. You can try the quiz link to solve more problems on this topic and get feedback. Keep practicing, keep shining. All the best.